Hello everyone and thanks for watching Edupedia World videos. I'm Manish Agrawal and in this session of mole concept we'll start with concentration units. Alright, and we'll see why concentration units are used and some examples of these units. Alright, so before we start with concentration units, we need to know about solutions. Alright, we need to understand what solutions are and how do we classify and quantify them. Alright, this is quite important because most of the chemical reactions and chemical processes actually take place in solutions. Alright, so the chemical reactions that we studied in our previous sessions, they will be actually taking place in some sort of solution. So unless we know how to quantify solutions, we cannot actually make calculations for the reactions. So what is a solution? Well, it's very simple. A solution is a mixture of two or more substances. Right? It's as simple as that. It is simply a mixture of two or more substances. So when I say two or more substances, I mean that it can be a gas, it can be liquid, or it can even be solid. So say when you mix two gases like nitrogen, hydrogen, what you get is a solution, or two or more gases. So even if I mix 5 different gases, what I get is a solution. Alright. Similarly, if I mix a gas and a liquid, again it will be a solution. Okay. So I can also mix two liquids, say alcohol and water. So again that will form a solution. Okay. Or I can also mix, say, a liquid and solid. So when you add salt to your water or sugar to your water, okay, you get a solution. Or you can add both salt and sugar to your water. So I have added 3 substances together, okay, and so this is a solution containing 3 different substances. So there are numerous examples of solutions around us, okay, and we are not going to go into details of them in this chapter. Okay, we just need to know that what solution is, and now we understand that. Okay, so mixture of 2 or more substances is a solution. Okay, even 2 solids can be mixed to form a solution, something that you call an alloy. Okay, for example, you can mix copper and zinc, alright, together to form an alloy called brass. Similarly, bronze is an alloy of copper with other metals like manganese or aluminium and maybe even non-metals. Alright, so solution can be a mixture of any 2 substances. Alright, so only thing is we are now going to classify solution into homogeneous and heterogeneous solutions. Alright, and for now we'll only focus upon homogeneous solution. Okay, we do not know what heterogeneous solutions are and we do not care about what heterogeneous solutions are. So what is a homogeneous solution? Well, a homogeneous solution is a solution whose composition is uniform throughout the container. Let's say I have a container, a closed container. Alright, now I have mixed alcohol and I have put in water. Okay, so I have mixed 2 liquids in this container. Okay, now this container, let's say it's filled like this. So when I say that this solution is a homogeneous solution, it means that its composition, that is the amount of alcohol, water which I take from this corner of the container, is going to be same as which I take from this corner or any other part of the solution. So when composition, okay, we already know what composition is. Okay, we have studied in percentage composition what composition is. Composition is amount of one substance relative to another. Alright, so when composition is uniform throughout the solution, okay, that is any part of the solution has same composition, then such a solution is called a homogeneous solution. Okay, when it is not uniform, when it varies, okay, in space, then it is a heterogeneous solution. So our focus will be only on homogeneous solution. So whenever I say the term solution, okay, it is implicit that we'll be talking about homogeneous solutions only in our course. Okay, so let's go into further details of solution. See, a solution is actually made up of a solute and solvent. Alright, so when I say that I have a solution of two or more substances, it means that I have solutes and I have solvent. Okay, so when I added up alcohol and water together to form a solution, then one of them has to be classified as solute and other has to be classified as solvent. Okay, similarly, when I added salt and sugar to my water, so I can say one of them is solvent, then rest of them, that is two other substances left, will have to be classified as solute. Okay, so how do I differentiate what is a solute and what is a solvent? Right? Well, there is no fixed rule about that. Okay, there is no rule that you have to call this substance as a solute and that substance as a solvent. As long as you have a solution, a homogeneous solution, you can call any one substance as solvent and you can call everything else as solutes. Okay, it doesn't matter. And again, in some other question for the same solution, you can call another substance as solute and other substances as solvent. Okay, so it doesn't matter what you call solvent and what you call solutes. Okay. But just for convention and just for sake of clarification, we try and follow some rule of thumb. Okay, which are: first, if there is water present in your solution, if there is water present, then usually we take it as solvent. Alright, if there is water present, we'll call it solvent. So when I added salt and sugar to water, I can say that water will be the solvent and other two substances will be solutes. Similarly, when I added alcohol, okay, when I added alcohol and water, I can say that water is solvent and alcohol will be solute. Okay, technically you can also call water as solute and alcohol as solvent. Okay, both are liquid, it doesn't matter. Okay, but by convention we'll take water as solvent if it is present. Okay, but there is no such fixed rule. For example, there are water droplets present in air. Okay, but in that case we do not take water as the solvent, right? Second rule, okay, if you don't want to follow this rule that presence of water will make it solvent, you can follow second rule, that is which determines the physical state of solution, and this is the most common way of doing it. Okay, generally whichever substance determines the physical state of solution is taken to be solvent. For example, in the example of salt plus water, after mixing, the solution after mixing is going to be liquid. Okay, it is going to be aqueous actually, but right, you get the idea. So which of them is aqueous? Water. Salt is a solid. Okay, salt is a solid quantity, so I can take water as the solvent and salt as the solute. Why? Because water determined the final physical state of solution. Similarly, when you have a sponge, okay, sponge you might have used or seen one. It is used for dusting or for plaster, okay, plastering of walls. So a sponge is actually a solution. It is a solution of gas in solid. Okay, the final state after mixing of the sponge, that is of the solution, is actually solid. Okay, sponge, if you see a sponge, what you will say? It is a solid. So in that case, the solid will be taken as solvent. Okay, and the other impurities or other gas or substances in it will be taken as solute. Okay, so this is the rule that we generally follow. Another way you can classify solute and solvent is one which is present in greater quantity. Okay, so if I have a solute and a solvent, let's say in this case I have alcohol and water. So if I have half liter of alcohol and 1 liter of water, then usually I'll take water as solvent and alcohol as solute. But if the case is opposite, I have 1 liter of alcohol. If I have 1 liter of alcohol and only half liter of water, then you might take alcohol as the solvent because it is present in greater quantity. Ultimately both are liquid, so both determines the physical state of solution. You cannot say one determine the physical state, other didn't, right? So I can go on to quantity, that since alcohol is in greater quantity, I can say alcohol is solvent in this case and water is the solute. Okay, but again there is no fixed rule. Okay, it is your choice at the end. So now you know how to classify solvent. So once you have classified the solvent, rest of the substances present in your solution will be taken to be, we will take them to be solutes. Alright, so solute is everything else left in your solution. Okay, so it doesn't actually matter. Let's see concentration units. So concentration units are actually used for measurements of solution. That's why we have to study them. Right, now we know what solutions are, we need to quantify them. For example, I can add say 1 spoon salt to my water, or I can add 2 spoon salts to my water. So I need to quantify that. Okay, and that is why we use concentration units. How am I going to do that? Say there is one student who says I have 1 spoon of salt. Okay, and there is another student that says I have 2 spoons of salt. So who has more salt? You will say that greater quantity is present with the second student who has 2 spoons. But when you go into details, you might find that the first student has 1 spoon of salt for 1 liter of water, and the second student has 2 spoons of salt for 2 liters of water. So in essence, actually both have same amount of salt, right, relative to water, because ultimately they have to mix that salt into water and drink it. So ultimately both have same amount of salt relative to the amount of water present. Okay, so in essence none of them has greater quantity than the other. So that is why we use concentration units. Alright, because they give us the relative amount of one substance in a solution with respect to other substance. So hence it gives us more accurate information about our solution. Okay, so concentration units will be used to quantify one substance relative to the amount of other substance. Okay, so usually we quantify solute with respect to amount of solvent, or we quantify solute with respect to amount of solution. Okay, this is the usual way of doing it, that quantify solute, you have many solutes and say one solvent, so I can quantify one of the solute with respect to solvent, or I can quantify one of the solute with respect to total solution. So based on how I am doing it, the concentration unit will vary. Similarly, I can quantify substances based on their mass, or I can quantify them based on moles. Okay, now we know what mole is. Or I can even quantify them based on their volume. Okay, so also depending on how I quantify the substance, my concentration units will vary. Okay, and depending on those variations, we have numerous examples of different concentration units. Okay, such as molality, they are both different. Okay, it is not like we have screwed it up here. Molarity and molality, these are two different concentration units. Okay, similarly there is mole fraction and lots of other concentration units. Okay, and we'll take them up one by one. Okay, at least those which are there in our syllabus right now and which are going to be useful for us for solving the questions. So let's start with some of them right now. Let's start with percentage compositions. Why? Because we already studied them. So we already have a basic idea of calculations related to percentage compositions. So let's study them from the point of view of a solution. Okay. So percentage compositions can be calculated in many different ways. Okay. For solutions, we'll usually quantify them in three different ways. First of them is percentage weight by weight. Okay, the first concentration unit that we'll study is percentage weight by weight. Alright, so what does percentage weight by weight means? It means mass of solute present in 100 gram of solution. Okay, let me clarify it for you. Say I have a solution. Okay, let's say I have a solution containing 80 gram of solution. I have a solution containing 80 gram solution. This solution is made of 10 gram glucose. Okay, this solution is made of 10 gram glucose. Okay, and rest water. Okay, rest of it is water, and in all it forms 80 gram of solution. Okay, so that is weight of glucose plus weight of water will be total weight of solution. Okay, that is quite obvious. We saw that solution is nothing but solute and solvent. So I can always say that solution is equal to solute plus solvent. Right? I can always say this, that solution is nothing but sum of solute and solvent. So all of the properties of solution, that is say total volume of solution, can be said to be volume of solute plus volume of solvent. Total mass of solution can be said to be mass of solute plus mass of solvent, and so on. Okay, so back to our example. If I have 80 gram solution, 10 gram of which is glucose and rest is water, then percentage weight by weight of this solution, percentage weight by weight of this solution will be mass of solute present in 100 gram of solution. That is how much solute is present with respect to total mass of solution. So I have 10 gram solute in 80 gram of solution. Alright, that is I have 10 gram solute with respect to 80 gram of solution. Okay, so this gives me the fraction, but I have to calculate percentage. So we multiply it with 100. Okay, we multiply it with 100. 10 by 80 multiplied with 100. That is why I wrote here mass of solute present in 100 gram of solution. Because when you calculate this fraction 10 by 80, what does this fraction represents? This fraction actually represents that if you have 10 gram glucose in 80 gram solution, then how much glucose do you have in 1 gram solution? Okay, so 10 by 80, this fraction represents amount of glucose present in 1 gram of solution, and when I multiply it with 100, I get the amount of glucose present in 100 gram of solution. Okay, so this quantity, percentage weight by weight, this concentration unit always represents amount of solute present in 100 gram of solution. Okay, so you can have a simple mathematical formula for calculation. Okay, that will be percentage weight by weight. This is the concentration unit that we have to calculate. Percentage weight by weight is equal to 100 multiplied with mass of solute in grams divided by mass of solution in grams. Okay, you have to be careful with the units. Okay, you can take mass of solute in kilogram, but then mass of solution must also be taken in kilogram. Okay, that is the mass units you have used here in numerator and denominator must be same. You cannot use two different units. Alright, so 100 multiplied with mass of solute divided by mass of solution. So solute comes above and solution comes below. Alright, so here it is gram, here it is gram, gram and gram will get cancelled. So percentage weight by weight, this concentration unit will actually be unitless. Okay, if you are asked what is the dimension of percentage weight by weight, well, it is unitless, it is dimensionless. Alright, so 100 multiplied with this will give you percentage weight by weight. Let's look up an example. 0.5 gram of solute is dissolved in 100 gram of solvent. you have to calculate percentage composition. Okay, it's very simple, straightforward question. You just have to calculate percentage composition. Now it doesn't say percentage weight by weight, but by default, okay, whenever you have been asked percentage composition, okay, and there is no further information given, we will always calculate percentage weight by weight. Okay, in some places you might also find it as percentage mass by mass, or you can say it is per mass percent. Okay, there can be different names like percentage weight by weight, or percentage mass by mass, or mass percent. Okay, or some people simply refer it to as percentage composition. Okay, so percentage composition means you have to calculate percentage weight by weight. So I have 0.5 gram of solute, so 100 multiplied with 0.5 gram of solute divided by, what is the formula, mass of solution. Now solution is what? Solute plus solvent. Solution is solute plus solvent. So what is the mass of solution? It is 0.5 plus 100, right? Solute is 0.5 gram and solvent is 100 gram. So solution will be 100 and 0.5, 100 plus 0.5 gram. Okay, and then you can make the calculation and report the percentage. Okay, next thing, see here 0.5 is much less than 100. Alright, so you can either do exact calculations. Exact calculation will be 100 multiplied with 0.5 divided by 100.5 gram. Okay, so obviously exact calculations are always preferred, but a lot of times you are in hurry. Okay, and usually this part calculation of percentage composition will only be one subsection of your complete question. Okay, so you cannot make accurate calculations all the time. So what do? We see that, okay, we note here that 0.5 is much less than 100. So I can simply neglect 0.5 with respect to 100. Okay, my answer will vary a bit, but approximately it will be same. Okay, so I can simply ignore, that is neglect 0.5 with respect to 100. Okay, and in that case I can directly calculate and see that percentage composition will come out to be 0.5%. Okay, so when can I neglect this? Okay, when can I neglect this? Okay, I can simply neglect. What did I do? I had two quantities, A plus B. Okay, and I neglected one of them. I assume it to be 0 with respect to other. Okay, you can always do this as long as this quantity, that the quantity that you are neglecting is less than, okay, if B is less than 10% of A. Okay, this is the rule of thumb that you can follow here. Whenever one quantity is less than 10% of A and you do not want to make accurate calculations, you can neglect that quantity. Okay, instead of addition, if there was subtraction, even then you can neglect that quantity. You cannot do that if there is multiplication or division here. Okay, we'll do this neglecting one quantity only when there is addition or subtraction involved. Okay, and this rule of thumb, this is what we usually follow. Okay, some people they want to be more prude about it. So what do? Instead of 10%, they will neglect only when it is less than 5%. So instead of 10, we might have 5% of A. Okay, some other places you might find that quantity is neglected only when it is less than 1% of other. So when B is less than 1% of A, only then I can neglect that. And if we take this to be case that B is less than 1% of A, then we cannot neglect 0.5 with respect to 100. Okay, in that case I will have to, we can still neglect 0.5 with respect to 100. Okay, it will be 0.5%. So it is still less than 1% of A. Alright, so now you know how to neglect the quantities as well. You might not need to use it over here. Okay, you might make accurate calculations because ultimately they are not really difficult, these calculations. Okay, but if you want, you can also neglect them and calculate approximate answer. Okay, let's see the next concentration unit. The next concentration unit is percentage volume by volume. Okay, and this is how we represent it. Percentage volume by volume. It calculates volume of solute present in 100 ml of solution. Alright, it is exactly same as percentage mass by mass, that is percentage weight by weight. Only difference is instead of mass, now we will be talking about volume. Okay, so percentage volume by volume will be 100 multiplied with volume of solute divided by volume of solution. Okay, all the concept, all the theory behind it is completely same. Only difference is now I need to calculate volume of solute and volume of solution. Again, they both must be in same units. Okay, so usually by convention we take them to be in milliliters. Ml is milliliters. You can take them in liter, but make sure that both of them are in same unit. Okay, so that our final unit will be dimensionless or unitless. Okay, again percentage volume by volume will also be unitless. Let's see a quick example. Okay, and we'll move on to the next concentration unit. 5 centimeter cube of alcohol is dissolved in 20 centimeter cube of water. Calculate percentage composition by volume. See, now they didn't write percentage composition. They clearly mentioned you have to calculate percentage composition by volume. Okay, so percentage volume by volume is 100 multiplied with volume of solute. What is the volume of solute? Okay, alcohol is in less quantity and water is in greater quantity. Moreover, it is water, so I can take water to be solvent and alcohol to be solute. So I can calculate, I can write that percentage volume by volume is actually percentage volume of alcohol with respect to volume of solution. Okay, here V by V represents volume of solute with respect to volume of solution. So 5 divided by volume of solution is 5 plus 20. Okay, solute plus solvent gives me solution. Now you cannot neglect 5 with respect to 20. Okay, you cannot neglect 5 with respect to 20. It is a big quantity. It is in fact 25% of 20. So you cannot neglect 5. So what do I get? 5 divided by 25 into 100. Okay, and that will give me the answer. Okay, it should come out to be 20%. So 20% volume alcohol is present in every 100 ml of this solution. Alright, answer comes out to be 20%, means for every 100 ml of this solution I will find that 20 ml is alcohol. Alright, next, percentage weight by volume. Again same funda. Okay, there is no change. Only difference is now I calculate mass of solute present in 100 ml of solution. Okay, so in this case the formula becomes percentage weight by volume is equal to 100 multiplied with mass of solute in grams divided by volume of solution in milliliter. Okay, now this time you have to ensure that mass is always in gram. You cannot use kilogram, pounds or any other unit of mass. You cannot use milligram. Similarly, you have to ensure that volume is always in milliliter. You cannot use centimeter. Yeah, you can use centimeter cube because 1 ml is equal to 1 centimeter cube, but you cannot use meter cube or liter. Okay, and this also implies that this won't be unitless. The unit of percentage weight by volume will be gram per ml. Okay, this concentration unit is not dimensionless, it is gram per ml. Let's see an example to make it more clear. 10 gram of salt is dissolved in 20 centimeter cube of water. Calculate percentage composition by volume. Alright, so I have 10 gram of salt. If this 10 gram of salt is dissolved in 20 centimeter cube of water, so I can take salt. Okay, I know that finally since water is present I can take it to be solvent, or I can see that since final state is going to be liquid, okay, aqueous, so I can take water as the solvent. So 100 multiplied with 10 gram of salt divided by volume of solution. Now what is the volume of solution? It is the volume of salt plus volume of water. Okay, you know that volume of water is 20 centimeter cube. It is given to you in the question, but you do not know volume of salt. Okay, because we have to use volume of solution, we have to add volume of both solute and solvent, but I do not know the volume of salt, so you cannot make further calculations in this question. Okay, so what do? Either I leave it over here and say that there is insufficient information, or I be smart about it and I make some assumptions. Okay, I approximate the answer. How do I approximate? Well, salt is a solid and water is a liquid. So solid usually have much less volume than liquids or gas. Okay, for example, you take 1 liter of water and you take 1 spoon of salt. Alright, so even by comparison, by just visualizing that situation, you can see that how much less the volume of salt is. Okay, so I can always neglect when I do not have sufficient information, but what I have is a solid. Okay, what I have is a solid being mixed with a liquid or with a gas. Then what can I do? I can always neglect volume of solid with respect to volume of liquid or volume of gas. Okay, I can assume it to be 0. So here I have volume of salt, so I can assume it to be 0 with respect to volume of water. Okay, similarly, if you have volume of liquid plus volume of gas, if you have just a liquid and a gas, a solution containing these two quantities, and you do not have sufficient information, then in this case you can neglect volume of liquid with respect to volume of gas. Okay, so you can say that this is approximately equal to volume of gas, because again volume of gas is much greater than volume of liquid. Okay, in relation we can always say that unless we have sufficient information. So here I can say that percentage weight by volume will be 100 multiplied with 10 divided by 20 centimeter cube is ml. Okay, 1 centimeter cube is 1 milliliter, so 20 ml. So this is equal to, okay, 50 percentage weight by volume. Okay, this is your answer. Okay. So these are some of the concentration units that we have studied. In the next few sessions we'll continue with concentration units, but we'll study some different units. In the next session we'll do molarity, alright, and then so on. So until then, and once again, thanks for watching Edupedia World videos.